All right. So we got a basic idea of what filament printing is, but how do you do that? So essentially, what the process is, you have your model that you've already created in CAD, Fusion 360. We need to take that out of Fusion 360, send it through a slicer program, which is the program that takes your solid 3D object model from CAD and prepares it for 3D printing to take it from there, slices it into a whole bunch of layers, slicer, and converts it to what's called G code. G code is just a different kind of computer CNC, computer numeric control code. It's very common in 3D print, or it's the standard in 3D printing as well as CNC manufacturing and such. It's the same kind of coding that takes your model and tells the machine how to move to make it do that, or to make it. Pretty much it. So what are we using? How we do that? Well, the program we're using is, well, I recommend the PRUSA Slicer, but MakerBot also has its own proprietary slicer. The difference being, and mildly irritating, they make you actually make an account and everything to use their slicer. So there's a third option, which is a more universal slicer called Utilimaker, or rather Cura Slicer. That is where the Utilimaker comes in. All right. So let me share my screen and let's start with the first part. Got Fusion, got our object. Let me hide the canvas here. This is the model that I made before, my little Star Wars Rebel Scum thing. So I made to size. Checking my proportions, just double checking here, using the inspect measure tool, selecting the outside ring here. How big is that radius? 56 millimeters radius, which means 112 millimeters diameter. Perfect. That's a good size. So you'd select your object, and you can either just select the body. In this case, selecting the whole component. Problem is, when you select the whole component, it also grabs like any hidden sketches, canvases, stuff like that. So I recommend going down your browser tree, your hierarchy tree, expanding bodies, and selecting the actual body. Works a lot better that way. From there, go up to the top, go to File. Now you would normally expect to hit Export, and you can. That's fine. You hit Export. You just have to make sure to select what kind of file. And in this case, the only option that comes up immediately is the 3MF style. And what we're doing for now, that's probably a little bit more than you need. And some slicer programs don't readily take that. So if you want to stick with a more standard, you could either select STL or OBJ. The other option is go to File. The next one down is 3D Print. So it automatically goes right to that. Go to select 3D Print. Toolbox pops up. You will have the same option. Do you want STL, 3MF, OBJ? You have two options in STL. Just stick with the default binary. That's perfectly fine. For this first project, stick with STL is perfectly fine. However you approach it, export or 3D print, that's fine. But if you select 3D print, make sure you deselect the checkbox that says send to 3D print utility, because Fusion does actually have a 3D print utility built in. I don't much care for it. That's just me personally. You make that choice. Select OK. And then, like anything else, I'll throw that in my downloads and download it. Now it's out as an STL. There we are. You can get the same thing. Select there, going to export, scroll down to STL. The reason I go to 3D print is, as it says here, requires cloud translation, which really doesn't matter, but sometimes it can take longer for whatever reason. So select there, you'll get a progress bar, but it was instant, so we're good. So if I go to my, oh, there we go. Now it's giving me the progress bar. So see here, I don't know why it takes longer. So that's why I go to the 3D print option. You get the exact same result, no change whatsoever. Just know that that's how long that takes. All right. Well, super duper. Let me switch my share here to just the whole screen here. Alt over there into that. Now, where do you get these slicer programs? Well, open up your browser, and if you want to use the direct PRUSA, go to PRUSA Slicer or PRUSA3D.com. Just search PRUSA Slicer, you'll get there. Or the same thing happens if you go to select Cura. It is called a Cura Slicer. They are both good. You have options for, yeah, sure, whatever. You have options for systems. So if you're on a Mac, obviously Mac or Windows, same diff. Going to PRUSA Slicer, same diff. You have the options for Windows, Mac, that sort. Now, the only difference in this effectively is that the Cura Slicer can prepare objects for the MakerBot. The PRUSA Slicer will only make it directly for the PRUSA printers. That said, I like the interface and output effectiveness of the PRUSA Slicer versus the Cura Cura Slicer. Same diff, your choice. Because I prefer the PRUSA Slicer, I'm going to show you that one. And if you want to learn this one, I'll certainly show you that as well. So in this case, I'm going to PRUSA, select download for Windows. Just like downloading anything else, you're all set. Open it up out of your downloader, install. So I already have it installed on the computer, but good thing here is I get to also take you through the setup, because it does take you through a quick setup. Just because they make a bunch of different products, same thing, you'll deal with the exact same thing, different, just slightly different interface if you download Cura. So that's your standard configuration thing. Yep, hooray, thanks and welcome. Go to next. Now this is where you have to be careful just to make sure you're selecting the right one. It default selects the mini one here. We don't have one of those. So deselect that. This Mark III family, the second row, that's what we have here. Both of those are Mark IIIs. Doesn't matter which one of these you select, but just stick with the first one because that's the first one. That's the one we actually have. The other ones are just set up to, there's an option, there's an add-on equipment that can let you print from multiple materials at once. We don't have that, so ignore it. And we have a 4mm nozzle. So all you're doing, selecting first one in the row of the Mark III, 4mm nozzle, that's it. We don't have any of those. You don't have to bother with the vendors or anything. That doesn't matter. You can make your own custom profile because it's your thing, but I'm skipping that. It will default select a couple of filaments. You can select the PRUSA made filament, but honestly, I found no difference than using the generic setting as well. You can select all of them and everything if you want. That's fine. Select all of them. Now you just have a bunch to sift through. Totally up to you. But the main thing is make sure that you have PET and PLA of somebody's make. That's really all. If you want to select those on here, super duper, you can always go back and fix and add stuff later. That's it. Now, the reason it's important to select what printer you have is just like within Cura, this will give you a virtual representation of the print bed. So that way, when you bring your object in, you can get a real scale sense of how large your object is. If it's too large, you need to scale it down, or if it's too small, you scale it up and you get an immediate sense. This is 1-to-1. This grid, I believe, is relative, or I believe these grid squares are, I can't remember, let me grab it. See these magnetic sheets. I can't remember the size. So these squares on here, the larger squares, all right, they're 50mm or 5cm squares. So that means that each of these is 1 centimeter or 10mm. So there's your relative scale there. Pretty straightforward. Now, standard interface here. First things first, let me bring my model in. You can either file and open new project, or you can open the folder and drag and drop. Same diff, does not matter. Now you see here on the I have my downloads here. One I exported from, or one I exported from Fusion 360. The other I used through the 3D print utility. They're the exact same file size. There's no difference whatsoever. Simply whatever you choose. You can drag and drop. Whoop. And there you go. Plops it down. Now, you might have accidentally put this in a different orientation, stuff like that. Not a problem. You can move your objects around, or if it's small enough, you can select add more. If you're adding more of different objects, or you can select copy and paste. You have some automatic stuff here. You have, of course, your add or subtract, delete, or just press delete. This is an auto arrange. It'll map them out however it thinks is best. You can arrange them however you think is best. It will change color and it'll give you an error if you're outside of the boundary. For this case, I'm just going to delete one. Whoops, I mean to delete both, just one. That's okay. There we go. Smack in the middle. These are just different layers, searching, different heights. We'll deal with that kind of stuff later. If you bring your model in and say it's the wrong orientation, you can do this manually, or rather, let's go down the list here. You have move, which you can select, or you can just drag, or you can just click and drag your object around. Again, you can use the auto setting, it'll plop it there. You have your scale here. You could do this manually, or if you look to the right, there are numeric inputs, just like in Fusion. Your scale factor is a percentile. You'll see the scale factor, it starts as 100%. If you want it half size, 50%. Undo. If I want it twice the size, 200%, so on and so forth. Obviously, that's way too big. There we go. If you have brought this in, and I'm just going to move this at a different angle, and that's cool. It already snaps above the board there. If you have built this on, say, a different plane, well, say the wrong plane, just excuse me, a different plane. Say like you inadvertently built your model on like the instead of the XY axis or plane, you built it on the XZ or YZ plane. It'll be oriented upwards. You can do that manually and try to get it to line up flat, but in filament FDM style printing, you want your object as flat on the bed as possible. And that's why we start with this design, flat smack on the bed. Convenient thing is both Cura and the PRUSA Slicer here have an automatic orientation, which is the next one, place on face. You select that button and you can see that it's highlighted the major areas. Even though this has all the detail and text and such on this side, if I select that side, smacks it face down. But it's gonna be better if it's the other way. So select that one. Plop. I don't know why it turned it. So it doesn't really matter. That's kind of weird. Anyway, the last selection on here is cut. This is something if your object was too large, like you wanted to build something that was too tall for the actual print volume, you can actually chop it in half and then move them over and drop both halves onto the print. So don't need to deal with that right now, so we're not going to. All right. The other major options are, yes, you have tabs up here. It might be simpler if you have these other tabs on the right side. There's a simple setup, advanced, and expert. We'll just keep with simple or advanced, same diff. There's a few different options here. Basically, staying in the simple mode, cool. Cura has the same options. Main things you want to adjust, your print setting. Now, this is a drop down. You can see we have the ultra fine, super heavy extra detail. Do not use these. These are not good for our settings. These are better. These are intended to be used for smaller diameter nozzles. Ours is a 0.4 millimeter standard. So I recommend sticking with something more of like at least a 0.2, which you have two options, quality or speed. For this project, those are going to be pretty interchangeable. And the third option, draft. Just like if you're printing a paper, you usually have draft and detail mode. Detail mode is going to use a lot more ink and it's going to take more time. Draft uses a little bit less ink and it spits it out faster, unless you're using a laser printer, and that doesn't Same diff. These numbers next to each other, 0.3, 0.2, 0.2, 0.15. These are the layer heights. These are the thicknesses of each increment that it moves the print head away from the print bed. So draft, it moves it 0.3 millimeters each time. So it's going to be a little bit thicker. 0.2, only 0.2 millimeters. You get the idea. So in this case, I'm going to select draft. Now, make sure that you have the material you want. We're going to go over selection here in a few. You're welcome to use either PLA or PET. The only difference being, make sure you have the right one, because this program will program in the temperature settings for the appropriate material, or the appropriate temperature settings for the material. So it's imperative that you select which one you want. You can make one of either, and then you can just make that choice later. The selection of material has no bearing whatsoever on the color. It's merely the base material. So if I select PLA, or PET, if I select PLA, it does not matter what color I choose of the actual filament, so long as any of the filament I choose is PLA. If you only selected the Mark III printer, that's the only option. So there you go. You need to make sure you're using that one. They all have the same temperature settings, but it's going to be a different bed and different controls and stuff like that. So that's all. So make sure it's got that. Supports, we don't need to bother with right now. That's something we're going to discuss with the next project. But basically, your supports are the scaffolding that gets built around an object to help support it on the print bed. The main other thing you want to look at is this choice in infill. For what we're doing, you can leave it at 20%. This is simply the density it prints the inside. 3D printing in filament printers, FDM printers, unlike SLA printers basically print a solid object. Unless you have actually modeled in a hollow space, SLA printers tend to print as a solid object. Are there options to do that? Of course. For FDM filament printers, you are creating an object. It prints the shell, the outside is the detail that it's focusing on. The internal space, the internal mass, the internal volume, it creates a patterned infill. It takes up the space. It creates, through your choice of pattern, it creates a pattern inside that helps support the whole thing, all of that. The infill percentage is how dense or how sparse that is. 20% is very good for what we're doing. You don't need it to be solid, that's for sure. 0% means it's totally solid. For what we're doing, 20 is perfectly fine. You can even get away with 15. The only difference with that is it might shrink your print time a little bit. You get all this stuff done, you decide what you've done, you've got your scale set, you've got it oriented, great. Last thing to do, go down to the bottom, select Slice Now. It's going to prep it. Now it's shifted to another view. This gives you a legend up here of what each color means. When I zoom in, you can see all of these lines and such like that. As I rotate it around, you can see these lines on the outside. These are direct representations of how the actual filament extrusion will look on the object. All of these different layers, that is representative of how many layers it will take to create your model at the thickness, or rather the print setting you have chosen with the filament you have chosen. If I were to zoom back out, there's this slider here. This is going from the bottom all the way up to the top of it. I can drag this down and you can see it slicing away and removing different layers, and it will expose the infill. And you can see in this case, it is a cube infill. Looks like a waffle pattern. So empty space inside is filled up with this. If I were to choose much more dense, let's say 70%, I reslice, you can see how much more dense that grid pattern is. That's what that means. For this case, 15 or 20% is perfectly fine. Oops, I should have showed you the difference there. Let's keep it at 70%, and let's show you something else on here. The PRUSA Slicer or Cura, most of them will give you an estimated print time and the amount of material. They'll even give you a cost breakdown if you have the right settings. We're not going to worry about that. At this density, printing this whole thing all the way full, this will take just over 2 hours. If I change the density to the infill to 15%, reslice, same thing. Now it'll take 1 hour 48. So a little bit more sparse, you can save on time. You can save even more time on different patterns, which are under print settings. Don't have to worry about this right now. Under infill, your different patterns, you can play around with this stuff. I usually use the gyroid pattern. I like it because rather than making an individual square, the thing has to start, stop, all kinds of stuff. Let me slice and I'll show you what I mean. No real change on saving time. But as I pull the slice, as I pull the layer thing down, you can see the different pattern. It's more of this wavy line. In more complex and larger, denser things, it saves a little bit of time. But for right now, you don't have to worry about it. Just use the default settings. You can stay at 20%. That's perfectly fine. Any of that. So slice now. Great. Hour 51 minutes. Cool. So this is what I mean by these can take a long time to print, but it's not like you're using a whole bunch of material. It's simply that's how long it takes for that heated material to cool enough to where it can create the next layer and move on. That's all. Final step for this, export G code. And you'll see it's as a G code, and it'll save both your file name, the thickness it is, or the print setting. This is draft mode 0.3 millimeters, saves the material, the printer, and the time. Really convenient because that's going to show up on your screen when you're putting this into the printer. Save. All righty. Now this next part I can't really show on screen, but I'm working on a separate video to walk through so I can actually show you this. Now the thing is, you have to put this on a drive. Let me go over here and I'll show you real quick. We have a bunch of these floating around. And I have 3D printed these little tabs so they're easier to not lose or harder to lose. Yeah, we'll go with that. All right. So it goes on a SD card. Just need a reader. We have these floating in the room. So if your computer doesn't have an SD card reader, we have these multi-readers you can grab. They should be one on each of these desktops, and there's one right here. Just plop it in. Take it over to and I'm just dragging and dropping it onto there. So let me do the share screen. I'll go to downloads here. There we go. You can see I just have it on there. I'll just copy, go down to, why is it not reading? Ugh. Hang on a second. Let me change USB ports in this computer. The sidebar, even though it's there, doesn't always read. There we go. So I copied this, open up the SD card. You can see it's saved a whole bunch of these. Paste it into there. There you go. Close it out. Then you just take this SD card over to the printer. It will automatically, it will start with this. You can select it. I'm going to show you all how to do this. You make sure you select your right material, heat up the printer, feed it in, clean off the print bed, hit go. That's pretty much it. Obviously, there's a lot of details to it that you really need to actually see, but that's pretty much the rundown. So gonna end this video. I'm going to show you all directly how to do this. Start the printers, and y'all are welcome to print anything you want within reason, anytime. Obviously, if there's a class in here, probably wait till after class, but come back at 3 in the morning and start a print, or come back at 4 in the morning and take a print off. I don't know, whatever your sleep schedule is. So I'm going to stop this video, and then I'll show you how to actually run these printers.